Hello everyone, I hope you are doing well. In today's video, we are going to solve the geometry problem from IMO 2024. Problem number 4. The Let me just read the statement for you. So we are told to let ABC be a triangle where AB is less than AC is less than BC. So basically, it's a scalene triangle. Let the incenter and incircle of triangle ABC be I and omega respectively. Let x be the point on the line BC different from C such that the line through x parallel to AC is tangent to omega. Similarly, let y be the point on the line BC different from B such that the line through y parallel to AB is tangent to omega. Let AI intersect the circumcircle of triangle ABC again at P not equal to A. Let K and L be the midpoints of AC and AB respectively. Prove angle KIL plus YPX is equal to 180 degrees. Okay, so this is L, this is K. So we have to find out KIL uh, plus. We have to find out the other angle. Okay, for that we know that we have we select a point X on BC that's parallel to AC. Similarly, we select a point Y uh, and draw a parallel to like AB. Okay, so AB is parallel to, let's say this, let's name this y dash and this x dash. Just okay, and we have like the AI. We will extend AI that will touch a point on the circumcircle P, and YPX we have to find out what KIL, angle KIL plus angle YPX is equal to 180 degrees. Okay, so let's join these things. As we have the angles, we're going to join them. Okay, so yeah, let's just join them. This is why. So what can we do? At first, as we said that I is the incenter, that means this angle and this angle will be equal. Okay, this angle and this angle is equal. We can extend this x dash and let's name it Z. Okay, and ZA is the intercept of the parallel lines ZX dash and AC. We have to prove this, and we are talking about the things we are seeing here. X AC and ZX dash are parallel. Okay, these two are parallel. That means this angle is equal to this angle. Okay. Okay. Again, from the similar reasoning, if we extend this and this is somewhere like Z dash, then this angle will be equal to this angle. For alternate angles are equal. Okay. So for that reasoning, we have these two angles equal. These two angles are equal. How does that help? How does that help? Let's draw a perpendicular from this point I to AB and I to this, and by that reasoning we get like, let's say this is T1, this is T2. Let's draw a T3 here and similarly T4 here. All of them are equal, right? All of them are equal. As they are perpendiculars, that means they will be equal. Let's not draw this for now. Okay, then what do we have here? Acha. So this angle and this angle was equal, right? A minute ago, this angle and this angle was equal. So that means ax dash is equal to x dash z. Okay. So from that reasoning, ax dash is equal to x dash z. So x dash a is equal to x dash z. From where what can we say? X dash t1 is equal to x dash t3, right? Because this is the same as radius r. This is the same as radius r. This this part is equal to this part, and that means this part is equal to this. Okay. So from that we can say this part at1 is equal to t3z. At1 is equal to t3z, and this is equal. That means these two triangles at1i and it3z, they are congruent. They are congruent. That means ai equals to iz. Okay. Then let's see. Let's just remove all this. Let's remove all this. Okay. From similar reasoning, we can say IT1, IT1 is equal to IT4. Okay. And due to like this is the 90 degrees, this is 90 degrees. And so this length is also this length. Okay. So, and this length is also that length. So from that point, we can say because this angle and this angle was equal, y dash z dash is equal to y dash a. Y dash z dash is equal to y dash a. Y dash a. And from the same reasoning, we can say that this part and this part is equal. That means this part and this part will be equal. So let's remove all this. We do not need them anymore. Okay. Okay. Now we need them. There is another congruent triangle, right? This one and this one is equal. This one and this one is equal. That means the whole triangle will be congruent. That means AI is equal to IZ dash. AI is equal to IZ dash. Both Z and Z dash, they are on the same line and they are equidistant from I. That means Z and Z dash are not different. They are the same point. They are the same point. Okay. How does that help? How is that going to help? Let's connect BP and CP. Let's connect BP and CP. And let's just see. Uh, for the same arc, we will have the same angle, right? So for CP, we have this angle here and this angle here. That means this angle was equal to this angle due to like parallel lines. So this angle is equal to this angle. Okay. Similarly, on the arc BP, this angle is equal to same as this angle, right? Both of them are on the arc BP. Okay. Same arc, same angle. Same arc means same angle. Okay. So let's just if you just get my point, then this we can remove all this extra stuff. So similarly, we get what? This angle is equal to this angle, and this angle was equal to this angle, and they both are equal. So, anyways, this is equal to this. Okay. How does that help? How does that help? this triangle, this was this. Okay, how does that help? We know a property, right, of cyclic quadrilaterals. Okay, let's just draw the things like perfectly right now, because we already have proved that z and z bar is same. So why not use the proper prop I mean quite proper archi, not the exact proper but almost proper, almost proper diagram. Let's draw it. So we have a thing called this angle is equal to this angle. That means uh, this angle and this angle equals to 180 degrees, because this and this angle is in the same line. They are complementary angles. So that means XZBP is cyclic quadrilateral. That means they are on the same circle, and due to that reason, the arc XZ, the arc. Let's just draw the XZ arc. Okay, the arc XZ has two angles. One is this one, and where is the other angle? Where is the other angle? Let's just draw it. Let's draw it. This one. Okay. So we drew the other angle. This will be equal. These two will be equal. Similarly, from the same reasoning, if we connect these two, while YZ, where is my YZ? This is my YZ. Okay. So while being, let's remove all that. Acha. So in here, like YZ, this angle was equal to which angle? This angle was equal to this angle here. That means this and this angle in total they are 180 degrees, and that means YZCP is also a cyclic quadrilateral, which implies that this angle here is equal to this angle here. Okay, so so far so good. So far so good. We had like midpoint K and L, midpoint K and L, and we joined these two here. Now what do we need? Now it was the Z point. We have find if we just uh, analyze steadily, then YPX, that is already resolved. This angle and this angle sums up to YPX. So we need this angle. How to get this angle? If we can show that that angle there and this angle here is same by any means, then that will be very easy for us to prove. Okay, so uh, this is the midpoint, right? AL is equal to LB and AI is equal to IZ. So both of them are midpoints. That means IZ, or sorry, IL is equal to BZ, half of BZ, and also parallel to BZ. Okay, so being parallel, what benefit do we get? For being both of them are parallel. Uh, as both of them are parallel, that means this angle here will be equal to this angle here, because the triangles are similar, right? We know it from like grade 9 mathematics that IL and BZ, they will be parallel. Why parallel? Because This is the midpoint, this is the midpoint, this is the midpoint, this is the midpoint. I is the midpoint of AZ, L is the midpoint of AB. So when we join two midpoints, that is parallel to the base and half of it. Okay, we know this theorem. So due to being parallel, the ALI is similar to ABZ. That means AZB angle is same as AIL. Okay. Similarly, we can say that for this angle, CZA is equal to KIA. Why same reasoning? This is half. I is the midpoint of AZ and K is the midpoint of AC. That means IK is parallel to CZ. The drawings may not be like exact, but from there we can say that this angle here is equal to this angle here, and that completes our proof. A triangle, all the interior angles will sum up to 180 degrees. So what we did here, we proved that this angle here is equal to this angle here, and we proved that this angle is basically these two angles in total. That completes our proof. So hopefully we understood. Okay, so we had to use cyclic quadrilaterals here, some basic property of triangles, and we are done.